Hello everyone, my name is Arun Bawa and I am PhD candidate in South Dakota State University. Here I am presenting a field study where we tried to quantify the changes in nutrient concentration leaving the plots through the tile drainage system after planting the rye cover crop. First of all, a brief overview of the study. The study is conducted over 3 years, 2018, 2019 and 2020. I don't know we were lucky or unlucky that we received three extreme climate conditions for all 3 years, especially for the spring period when the tile drain plays a crucial role to ensure the timely plantation. During 2018, we received 234 mm higher precipitation than average, and these higher precipitation were well distributed throughout the year. In 2019, we again faced a record high precipitation during the spring period as 75 mm of this additional 180 mm was only occurred during the May month. Whereas for the very next year, 2020, we faced a dry spring, and this the study is conducted in the South Dakota Research Farm of South Dakota State University, located in the Beersford, South Dakota. The study is conducted over the 12 plots with the six application of two treatments. The treatments are cover crop and no cover crop. The study results, combined with these extreme weather conditions, emphasize on the role of the cover crop management in order to obtain the desired direct and indirect environmental benefits from the cover crop. The projected climate conditions indicates an intensification of tile drainage practices in the region, and with this intensification of tile drainage, uh, it will be critical to adopt the best management practices like the cover crop in order to achieve the ecological agricultural approaches. The study demonstrated the effect of extreme weathers and the cover crop management decisions on the desired direct and indirect environmental benefits of the cover crop in the fields. The upper Mississippi river basin have abundance of highly productive but poorly drained soils. Tile drain remove the excess water from these poorly drained soils and ensure early plantation and late harvesting. It lower the water table and provide the enough space for the optimal crop growth, which ultimately lead to the increased crop production. Due to the associated agricultural benefits, the tile drainage practices are considered as beneficial management practice. And the importance of this management practices seems to be increasing under the projected climate scenarios. According to the National Climate Assessment reports of Midwest and Great Plains, the regions are expected to receive higher precipitation during the spring, fall, and winter. In another study by Dr. Hay and Dr. Tode, they observed an increasing pattern of precipitation for the regions. The figure shows the increased amount of annual precipitation in the inches during 1991 to 2009 as compared to 1961 to 1990. So they observed annual 2 to 5 inches of increase in the annual precipitation for the uh, for the eastern South Dakota region. This The increased precipitation, especially during the spring season, is becoming the top reason for the um, crop failure for the South Dakota, and making the tile drainage practices as an integral part of agricultural practice in the eastern part of South Dakota. This slide shows the crop failure insurance claims during the 2018. We can see that excess moisture and drought are ranked 1 2 for the crop insurance claims in 2018. In 2019, due to the extreme wet spring uh, conditions, it resulted in around 60% of the crop failure claims due to the excess soil moisture conditions, uh, which hindered the timely plantation and the other agricultural operations during the spring period. Tiled in, due to the associated tiled in benefits, agriculture benefits with the tiled in practices makes tiled in practices as the beneficial management practice for the producers and the agricultural productions. But it is also a major pathway for the agriculture nutrients to leave the fields and fertilize the water resources. The figure shows the contribution of agricultural area in fertilizing the Mississippi River basin and nutrient delivery to the Gulf of Mexico. It is raising serious water quality concerns for the local water resources and leading to the situations like dead zone of Gulf of Mexico. Many strategies and best management practices have been proposed to reduce this nutrient loading to the water sources. Cover crop is considered as the cheapest and the most practical best management practices for the agricultural producers. Cover crops are widely demonstrated for their direct and indirect water quality and environmental benefits. But there is still concern among the producers for their benefits, especially in the regions like South Dakota with the short growing season window and cold, harsh climate conditions. There are concerns for the survival of the cover crop uh, under these uh, under these winter conditions and introducing all the uh, all the benefits, these environmental benefits during the spring period. Considering this, we planned this study in the southeast part of South Dakota, having poorly drained and highly productive soil at the South Dakota Southeast Research Farm of South Dakota State University. We selected the winter rye cover crop due to its winter hardiness and nutrient squeezer properties. Winter rye cover crop can survive the cold winters of South Dakota, bind the residual nutrients to the field when there is very low uptake, and provide these nutrients to the next cash crop in the next growing season. It will allow the residual nutrients to be utilized by the crops rather than losing through the leaching and generating the water quality concerns. For this study, we hypothesize that planting cover crop will reduce the losses of nutrients through the trial drainage discharge. The study also focused on the additional benefits of cover crop for soil health and agricultural production, but in this presentation, we are only showing the water quality results. The study is conducted in the Southeast Research Farm in the BS4 South Dakota. The red block shows the two blocks with the six replication with the three replication of each treatment in one block. The study is conducted under 2 year crop rotation of corn and soybean. We are collecting weekly samples from the field. We are also collecting the samples during the major precipitation events. We start the sampling in the mid-spring and up to mid-winters. We are analyzing six water quality parameters: nitrate, nitrite, ammonium, orthophosphate, total nitrogen, and total phosphorus. We are using AQ1 discrete water quality analyzer to determine the concentration of these nutrients into the discharge water. So this slide shows the the agronomic information. Uh, the cover crop was planted for the first time in 2017, and and we can you can see that a cover crop cover crop was planted by the end of the October month for all the 3 years, but spread out on the different dates. In the 2018, it was spread out on the 16th May before the planting corn crop, and in 2019, uh, co- the cover crop termination was delayed by the 23 days, and due to the dry conditions and conserve the soil moisture for the next cover crop, the cover crop was terminated earlier in 2020. Here are the biomass productions by the winter rye cover crop during the all three study years. 2018, which was a wet year and ended up with the high soil moisture conditions during the spring period. It hindered the cover crop growth, and we received only 224 pounds of biomass per acre uh, by the termination by the uh, corn for the corn plantation dates. In 2019, in order to achieve a significant cover crop growth, rye termination was delayed by the 23 days. It was terminated on the 8th June, and we can see a higher biomass production in 2019 as compared to 2018, and a higher new nitrogen uptake in 2019. 2018, due to the dry and conditions, the cover crop was terminated earlier with only 131 pounds biomass per acre. Moving to the water quality results, the table shows the average monthly nitrate and total nitrogen concentration in the least water for the year. For the year 2018, cover crop productions were low, which indicate that it didn't use much amount of residual nutrients on the field, and we did not observe the significant reduction in the nutrient concentration. The similar results were found for the total nitrogen as well. In 2019, we observed higher biomass production and higher nitrogen uptake by the cover crop. It reduced the nutrient least concentration significantly in the June and July month. For the other parameters, ammonium and total phosphorus, we didn't observe any significant reductions, which might be due to the less susceptibility of these nutrients to lose through the tile drain discharge. The results for the year 2020 are not analyzed yet, but initial inspection of the results suggest that there are also not significant uh, reduction in the nutrient concentration, which corresponds to the low biomass production from the cover crop due to the early termination in the year 2020. The results of this study suggest that the reduction for the nutrient concentration in the least tile drain water are dependent on the rye biomass production, and for those biomass production, these biomass productions are influenced by the spring moisture and the termination dates. This figure is from the another study by our lab in the same area for the same time period of 2018 to 2020, where the effect of different termination dates of for the rye biomass productions was explored, and we can see that after the mid-May, the rye biomass productions was increased exponentially. So it suggests that an uh, effective uh, cover crop management can result in higher biomass productions, and which can lead to the higher reduction in the leaching of in the least nutrient concentrations. Based on the preliminary results for this study, we can conclude that the water quality improvement benefits of the rye cover crop is parallel to the biomass production, and sometime we have to face this water quality and crop production trade-off, especially for the years like 2020, during that for the dry spring periods where we have to terminate the cover crop earlier to conserve the soil moisture for the next cover crop. The intensification of tilled practices in the region will increase the importance of cover crop practices for the ecological agricultural approaches, but the effectiveness of these conservation practices, these cover crop practices, will be requiring the effective management also to introduce the environmental benefits. With this, I would like to acknowledge UST NRCS for providing the funds for the study. I would also like to thank all the viewers for spending the time for this presentation and would love to receive all the questions and suggestions from the viewers. Thank you.